We're going to look at each of the 4 challenges that you guys had to work on. For the first challenge, it says Kelly rotates an object 180 degrees about the origin and then translates it 5 units to the left. Scott translates the same object 5 units to the left and then rotates it 180 degrees about the origin. Will their images be in the same location? Justify your response. So to do this, you want to make sure that you do each of their sequence of transformations and then compare that final location of point A double prime. And then we can make the conclusion after we've done the transformation. So the coordinates of A are 2, 3. So let me go ahead and write those down. So Kelly is going to rotate her point first. So a rotation of 180 degrees, if you remember, the rule is negative x, negative y, or opposite x, opposite y. So our point 2, 3 is going to become negative 2, negative 3. So you can choose to draw that point if you'd like. It's up to you. I have a hard time drawing it without my stylus, which is still not working. So you can see it's kind of there. That doesn't really look like a point. But then from there, we move it 5 units to the left. So if you count 1, 2, 3, 4, 5, that's going to put it, wow, it's a terrible point, but that's going to put it at, what is that, negative 7, negative 3. Okay, now let's look at Scott's sequence. He's going to move it to the right 5 units. I'm sorry, not to the right, to the left 5 units. So if you move it to the left 5 units, that is going to take that x coordinate and it's going to decrease it by 5. So it will become negative 3, 3. And you can count, negative 5 to that left if you want to and see where it's going to locate. Again, it's going to be really difficult to see on my graph, but you can see that little tiny green speck. And then we're going to rotate it. So we're going to use that rule, opposite x, opposite y. So that's going to make negative 3 a positive 3, and positive 3, negative 3. So it'll actually end up over here. Let's see if I can get it to draw at 3, negative 3, which would be about right there. So if you compare those 2 locations, they are definitely not in the same spot. And here's why. When you rotate it 180 degrees, that affects both x and y. And translating to the left also impacts x. So since x is being impacted 2 different ways, then the order is going to matter. You can also write the rule for each of these in coordinate notation, and when you do that, what you're going to find is they're not the same. So if we look at Kelly's rule, right, her rule would be, we already said you start, oops, hang on, let me make this right, that does not look good. You start by rotating, so we start with opposite x and then opposite y. And then because we move it left to the 5 units, we're going to subtract 5 from the x value. So that would be her rule. Whereas Scott, he went left first. So that's, oops, not a negative yet. That's x minus 5. Didn't move it up or down, so that's y. But then he rotated. So here's where it comes in. When you rotate it 180 degrees, everything becomes the opposite. That's not just x and y. That's also that negative 5, which will end up becoming a positive 5. So what you'll see is that those 2 rules will actually be a little bit different. One says negative x minus 5 and one says negative x plus 5. So they actually end up being 10 units apart. If you were to count the distance between those 2 A double primes, they would be 10 units apart. For number 2, we're looking at a graph. We're looking at the pre-image, which is the blue triangle ABC. And then we're trying to figure out what happened to get from the blue triangle to the red triangle. So I put that there are 2 transformations. It could actually be done in more than 2 transformations, but I kind of want to do the quickest point, the quickest way to get from one to the other. So to me, the thing that sticks out the most when I look at it is I can see that there's a dilation. It definitely shrunk. So we know that there's going to be a dilation involved in this. And so we can choose to do that first. We can choose to do that second. It's kind of how you visualize it. But let's talk about, besides dilation and narrowing in on that actual scale factor, what else happened. So what I want you to do is I want you to pay attention to the orientation of the triangle. So when I look at the pre-image ABC, right, if I'm naming it ABC, I am going in a clockwise direction, right? But when I call it A prime, B prime, C prime, I'm actually going in a counterclockwise direction. So what that tells me is that I have a a reflection going on. When you look at that, some people may have thought, oh, well, that rotated. And it actually doesn't rotate. It's reflecting because you have that opposite orientation. So we got to figure out, what line did it reflect over? We've talked about three main lines. We talked about the x-axis, which to me, if you look at the x-axis, it would have gone from the second quadrant down to the third quadrant, so it doesn't look like it reflected over the x-axis. Then we have the y-axis, which means it would have reflected from the second quadrant to the first quadrant, which that's not what happens. But then we also talked about flipping over the line y equals x. And that line y equals x is that diagonal line that goes through the origin and has a slope of 1. And so if we look at that, it looks like maybe, just maybe, it could have reflected over that line. So as we're looking at it, it looks like we have a dilation that shrinks, and then a reflection, definitely a reflection. We think it might be the line y equals x. So let's see if we can kind of sequence those together and get a little bit more specific and get the exact transformations that are happening here. All right, so let's start with the dilation. All right, we know it shrinks. Dilation that shrinks by a factor of, all right, let's figure out the factor. So we know it shrinks because it's getting smaller. Remember that when it shrinks, the scale factor will be between 0 and 1. So a lot of you said it's a fraction, could be a decimal. So what I'm going to kind of pay attention to is the length of BC. If I look at BC and I count that length, it's 4 units. When I look at B prime, C prime, and I count that length, it's 2 units. So that tells me that if it went from 4 to 2, that I got cut in half. So our scale factor is going to be 1/2. So what we can go ahead and do, if you want, and you don't have to do this step, but what you can go ahead and do is do that dilation so you can see it a little bit better on your graph. So if A was -0.48 and we cut it in half, that would become -2.4. B is -2.2, and that would become -1.1. C is -6.2, and that would become -3.1. So now if we compare those new points to the coordinates of the final triangle, the A prime, B prime, C prime, we can see the coordinates of A prime are 4, -2, B is 1, -1, and C is 1, -3. So if you compare that second set of coordinates to the third set of coordinates, you can see that the X and the Y coordinates swapped. And when the X and the Y coordinates swap, that is a reflection over the line y equals x. Now again, this could be done in different ways. I have seen students dilate it, then rotate it 90 degrees, and then reflect it over the y-axis. So that can definitely be done, but it's certainly more steps. So now to write a rule in coordinate notation, you should know that all coordinate notation rules start as x comma y, and then they're just giving you the instructions telling you what to do with the x and the y. So what did we do? Well, we dilated by a half, so that means we multiplied x and y by 1/2. So 1/2 x, 1/2 y. And then we reflected it over that line y equals x. So then they switched positions. So that means it ends up being 1/2 y, 1/2 x. And if you compare any of your points, like A, -4, 8, if I do what this says, 1/2 of y, that would become 1/2 times 8 would be 4, so that would be my new coordinate. And then 1/2 times x would be -2, and that becomes my new y coordinate. For number 3, it says reflect ABC over the x-axis and then over the y-axis, then write a single rule in coordinate notation. So we did do one similar to this in our notes. When you reflect over the x-axis, you can count or you can use the rule. And the same thing with the y-axis. So I'm going to go ahead and write the coordinates out. A is, let's see, 4, 8. B is 6, 3. And then C is 2, 1. So I'm going to do it using the rules. So if I go over the x-axis, the rule for over the x-axis is x opposite y. So that means my x-coordinates are going to stay the same, but my y's are all going to become the opposite. So that would be 4, -8, 6, -3, and 2, -1. Okay, I'm not going to actually draw it. I'm just doing it with the points. And then I'm going to go over the y-axis. And the rule for the y-axis is x becomes the opposite, but y stays the same. So now I'm going to take those second points that we just created, and now I'm going to do the opposite of x. So that would be -4, -8 stays the same, -6, -3 stays the same, -2, -1 stays the same. And so then you can graph those points. Again, because my stylus is not working, it's kind of hard to graph. I'll try. There's a double prime, -6, -3 is B double prime, and then -2, -1 is C. It looks so bad. C double prime. So it ends up looking, you know, something kind of like that. Yours should definitely look better using a ruler. But write a rule in a single rule in coordinate notation so you can look at it and try to visualize it, but you can also pay attention to your x coordinates. Come on, change. Oh my goodness, hang on one second. Let's pay attention, let's try this again, to our x coordinates. So 4 became -4, 6 became -6, 2 became -2. So all of our x coordinates became the opposite. Right? And then if we look at our y coordinates, 8 became -8, 3 became -3, 1 became -1. So all of our y coordinates also became the opposite. So the rule would be xy maps -x, -y, or opposite x, opposite y, which is really just the same thing as a rotation of 180 degrees. Again, we did one like that in our notes. All right, the fourth and final challenge is another one where we're looking at image and pre-image, and we're trying to decide the transformations. So I think it's pretty easy to rule out a dilation. The size and shape did not change, so dilation's off the table. Looks like there could be a rotation or some sort of reflection because they're definitely not sitting that same exact way. So to decide, take a look at the orientation. All right, the blue triangle ABC is our pre-image. So if I do ABC, I'm going in a counterclockwise direction. When I name my image, I am also going in a counterclockwise direction. So that means it has direct orientation and there is not a reflection. So we were able to rule out dilation based on size. We were able to rule out reflection based on orientation. So that only leaves us with a rotation and a translation. So it kind of forces us to use those two transformations. So now we just got to get the details. How many degrees did it rotate and how many units up, down, left, right did it translate? Before we can worry about translating it, we really need to get these triangles to kind of sit in the same position. So we need to figure out our rotation. So that is what we are going to do first. So rotation of, let's figure it out. Okay, so when I'm looking at the blue triangle, I notice that the C is kind of on top, the A is more to the left, and the B is kind of at the bottom. Now when I look at the red triangle, which is my image, A is now up top, B is kind of on the left, and C is more on the bottom. So remember that when we do rotations that we're rotating clockwise. So we want to think how many times would we need to turn it to get that A up to the top. So if we kind of rotate it one time, 90 degrees, A is not going to be on the top. It's going to be kind of more, kind of like on the bottom. And if we rotate it 180 degrees, it's still kind of sort of be on the bottom, more of like the bottom right. So if we rotate it one more time of 270 degrees, it should put us in the correct position. So really the only way to make sure that you have the right degree is just to try it. So that's what we're going to do. So I'm thinking it's 270, but let's try it. So A is currently, what is it? 1, 5. 270, the rule is y opposite x. So if I rotate that point, that means it's going to become 5, -1. So let's try putting it on there. Let's see if we can figure this out. Oh, it kind of got rid of my point. All right, B is currently 4, 2. If I rotate B 270 degrees, it's going to become 2, -4. Remember, I'm using that rule, y opposite x. So 2, -4 is right here. And then C, I'm kind of running out of room here. C is, what are the coordinates of C? 5, 6. So if I use the 270 rule, it's y opposite x, 6, -5. 6, -5, right here. So that would basically put your triangle like that. And if you compare that triangle that I just drew to The red triangle that was given to you, you can kind of see now they're sitting in that same direction. Like the points, A is in that top position, C is in that bottom right position, and B is in that bottom left position. So now we know our rotation of 270 is accurate. So now all we got to do is figure out, all right, well, how much are we translating? How much are we shifting to get our points into the right position? So our last step is going to be a translation. So let's see if we can count. This is going to be a little bit tricky because mine is, again, because I'm trying to use my finger, is not looking very good. But I'm at 5, -1. So I'm going to count over and up. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going left 8. And then 1, 2, 3, 4, 5, 6, 7 up. And that, if I do that from A, that would get me to A prime. If I do that from B, just to make sure, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Yep. And then C, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Yep. So that works for all of my points. So the last part is to do your single rule. So we know our rule is going to be XY maps. All right, so let's talk about what we did first. The first thing we did was we rotated it. We did Y opposite X. And then here's where it's tricky, because we went left 8. And when you go left 8, that impacts X. So your instinct is going to want to probably to put that -8 with that X. However, what you have to remember is that you switched X and Y, and so they took on new meanings. So your Y is now acting as your X. If you're going to go left 8, you are still going to put that -8 in the X position. And if you go up 7, you still need to put +7 in the Y position. So Y -8 and then -X + 7 is your rule in coordinate notation. That one's a little bit trickier, but you can check it. Like if you put 1, 5 in there, 5 -8 is -3. And that's the X coordinate of A prime, and then for 1, -1 + 7 would be 6, and that's the Y coordinate for A prime. So you can check to make sure that it works.